Good morning. Good morning, students. Okay, so we were talking about structure of atom, right? So, can any one of you tell me what we had discussed in the last class? Yes, good morning. Good morning to everyone. Yes, can you tell me? Okay. Can any one of you tell me what we have discussed? Okay, hydrogen spectra. Yes. So we have discussed about hydrogen spectra. Right? Now, what it gives the information? Hydrogen spectra will give the information about emission spectra or absorption spectra for hydrogen. Okay. Now, although we have taken hydrogen molecule, but due to the electrical this one, those atoms will get separated. So that's where we are going to get the hydrogen atom. So that's what you can observe in the textbooks. They will be mentioning hydrogen spectra is related to hydrogen atom. But which molecule they have taken? Hydrogen molecule or hydrogen gas. So that's where we have the hydrogen spectra. So which is an example for line spectra. Which is an example for line spectra. Now that's what someone had written. So we have seen Lyman series, Bohr series, then Paschen series, then bracket series, and the last one is Piffin series. That all depends on which is the initial energy level and which is the final energy level. All of you have understood? So that's what we have discussed in the last class. Lyman, Bohr, Paschen, bracket and Piffin. And even we have discussed about the equation. Even we have discussed about the equation. Which is that equation? Where energy will be equal to RH, right, into 1 by Ni square, 1 by Nf square joule. So that's what we have seen. Initial energy level and final energy level. RH is Rydberg's constant and Nf is related to initial energy level and final energy level respectively. All of you have understood? Any doubts related to this? In that case, first we will discuss about a very important one, that is Bohr's atomic model. Then we will discuss about or will solve some of the problems related to these equations. Okay? So before going to the solving of the problems, first we will discuss about Bohr's atomic model. Okay? So very important with respect to your exam point of view. Okay? So that's where we have the Bohr's atomic model. That's where we have the Bohr's atomic model. Okay? Now, what should be the first statement? First statement should be Bohr's atomic model is based on hydrogen spectra. So you should write first sentence as it is based on hydrogen spectra. That's what we can mention. First statement. Okay? All of you have understood? Before giving the postulate, better you should mention it as it is based on the hydrogen spectrum. Okay? Now you can start giving the postulates. Now we can give the postulates for Bohr's atomic spectra. So what is that postulate? That postulate here is, in an atom, electrons will be revolving around the nucleus. Electrons will be revolving around the nucleus. Electrons will be revolving around the nucleus in a definite path, in a definite circular path, in a definite circular path called as orbit. Called as orbit. You can underline the word orbit. In a definite path called as orbit. All of you have understood? So that's what the first statement. Electrons will be revolving around the nucleus in a definite circular path called as orbit, same as that of the Rutherford's model. Right? Similar to that of the Rutherford's atomic model. First statement. Now, second statement. Electrons will not be having, or electrons will not change the energy level. Electrons will not change the energy level with respect to time. What I mean to tell here is, an electron which is present in a circular path, in a particular energy level. See, for example, I have the nucleus and I have the atom. Fine. Now I have the electrons which are present at energy level 1. We have the electrons which are present at energy level 1. So these electrons, they will not move themselves to higher energy level. They will not move with respect to time. Got my point? So what I mean to tell here is, okay, I am explaining. What I mean to tell here is, in an atom, electrons will be present in a definite energy level. That's what the first statement. Orbit is nothing but energy level only. Okay? So they will be present in a energy level. Okay? Now, that electron, even after 10 minutes, it will be there only. Even after 1 day, it will be there only. Okay? Until unless you give the energy from outside. Until unless you give the energy from outside. Those electrons, they are not going to change with respect to their position or with respect to their energy level. All of you have understood? So I will write this statement. So electrons will not change their position, will not change their position, or I can tell energy level with respect to time. Okay, I will write here only. With respect to time. With respect to time. Okay? Now I can further tell that, or I can extend that with respect to time, until unless external energy has been provided. External energy has been provided. All of you have understood? So this is what the statement talks about. Second point. All of you have understood? So what I mean to tell here is, first statement tells that electrons will be revolving around the nucleus in a definite path. Okay, in a definite path, which is called as orbit. So orbit can be mentioned as the stationary state. Orbits can be mentioned as energy level. But with respect to energy, I will call it as energy level. With respect to path, I will use the word orbit. Okay, with respect to position of electron, I will call it as stationary state. So depending on the requirement, I will change the word. But otherwise, it is one and all same. All of you have understood? So that's what the first statement. Now, second statement tells that electrons will not change their position. Or you can tell that energy level. Or you can tell that stationary state. That's why it is called as stationary state. So electrons will not change their position with respect to time. That's what I told. After 5 minutes, electrons cannot change their position. Oh, I am sitting here, I am feeling bored, I will go to somewhere else. No. Okay? So that's what the second statement talks about. Now, further, I have extended telling that until unless external energy has been provided or until unless external energy has been removed. What I mean to tell you is there should be something from outside or from external region which has to play on those electrons. Otherwise, electrons are not going to change their positions. All of you have understood? Any doubt in this? Okay. So in that case, we will move to the third point, which talks about Bohr's frequency rule. Bohr's frequency rule. So what is that Bohr's frequency rule? It tells that electrons present in an energy level can take up only a particular frequency of radiation. Okay? So electrons in an energy level requires definite amount of frequency of radiation to move to the higher level or higher energy level. What I mean to tell here is, see for example, we have an electron here. Observe it carefully. We have an electron here. Now it has to move to the next energy level. And for that moment, there is a requirement of X joules of energy. But you are providing an energy of Y joule. You are providing the energy of Y joule. Then the electron is not going to move to that energy level. Only when it will take the X joules of energy, then only electron will move to that particular energy level. If you provide less than that, no. If you provide more than that, then also it will not move to that particular energy level. All of you have understood? Say for example, I want 100 rupees. But you people are giving me 90 rupees. I am very particular. I want 100 rupees means 100 rupees only. If you are giving 90 rupees, I am not going to accept it. Because there is a shortage of 10 rupees. And another candidate, he is providing 120 rupees. Then also I will not accept it. Because extra 20 rupees is there. So that's what it means to tell. So when an electron wants to move from one energy level to next energy level, only a definite amount of frequency of radiation will be taken. Okay? Only then it will move to that particular energy level. All of you have understood? Any doubts? That's what Bohr's frequency rule talks about. So why frequency? Frequency is directly related to energy. That's where we have h nu. So that means nu is equal to E by h. H is a constant. So which is the deciding factor? Which is going to decide the value for frequency? H is a constant. Can anyone? E is equal to h nu. So therefore, if I rearrange, it will become nu is equal to E by h, and h is a constant. Now can any one of you tell me? So since h is a Planck's constant, who is going to decide? Yes, it is both of you are right. It is energy. So that's what frequency rule. Although the word talks about frequency, in reality it is dealing with the energy. It is dealing with the energy of the radiation. All of you are absolutely correct. Okay? So that's what this third particular point talks about. Got my point? Please remember, Bohr's atomic model will be asked for 4 marks. So in that case, 3 points we have explained. Still we have to write another 1 point. Please remember, 4 marks, minimum 4 points. More than that, acceptable. But less than that, not acceptable. All of you have understood? So, shall I remove this one? So, what is that last one? It talks about frequency rule, Bohr's frequency rule, which tells that energy present in a particular energy level or stationary state, it will accept only that frequency of radiation which will allow it to move from that particular energy level to next energy level. Okay, so that's what it tells. All of you have understood? Shall I move to the next last postulate? Okay, so I will move to the last postulate. So we will come to next one, last point. Okay. Now with respect to the last point, okay. So it talks about. Okay. Thank you, Rohan. So with respect to the last point, it talks about why a particular electron should be present in a particular energy level. Right? Say for example, I have an atom where I have an electron 1 at this particular position. Why this electron should be present at that position only? Now all of us we know that is one of the reason is due to the energy. But still, why that E1 electron should be present at energy level 1 only? Why can't it can be present in energy level 2? So to answer that, he gave one particular reason. Okay, so that means where he talks about angular momentum of the electron, where he talks about the angular momentum of the electron. So where angular momentum, okay, where angular momentum of an electron should be having or should satisfy the following condition or following equation. Should satisfy the following equation. MEVR. Angular momentum. MVR, mass into velocity into radius. That is nothing but angular momentum. Okay, so which talks about velocity and which talks about moment of inertia. Together we are going to get angular momentum. Since we are dealing with electron, I have written it as ME. E should be subscript, or you can simply write it as MVR. No need to worry. But to be more specific, we can write it as MEVR. That is nothing but angular momentum. That is nothing but angular momentum, which should be equal to N into H by 2 pi. N into H by 2 pi. That means a electron can move in that particular energy level only when this particular equation will become satisfied. Or what I mean to tell you is, where angular momentum of the electron should become equals to n into h by 2 pi. What is n? Energy level. What is n? N is nothing but energy level. So which is the multiple of h by 2 pi. Which is the multiple of h by 2 pi. Got my point? So which is the variable then? Variable is only n. H is a constant, pi value we know. Right? So variable is energy level. So depending on which energy level the electrons are present, that value will be changed and it should be equal to angular momentum of that particular electron. Only when they become equals. So during that time only electron can be present in that particular energy level. All of you have understood? So that's what the first sentence does. Angular momentum of an electron in an energy level, I can write. In a energy level. In a energy level should satisfy the following equation, which is that one, MEVR is equal to N into H by 2 pi. If they are not becoming equal, if there is no equality, then that electron does not belongs to that energy level. It cannot happen. So that's what this particular statement talks about. All of you have understood? So what is that this statement tells? This statement tells that electron, why it has to be present in a particular energy level only. Why not in any of the energy level around the nucleus? So that's what this equation gives the reason. Okay? So you have to remember this equation to write this particular point. All of you have understood? Any doubts? Now finally it is related to properties or features of the energy level which Bohr gave. It is related to features of energy level. Okay, features of energy level. He only gave. Even you have to write this one also. Okay. Now it tells that stationary states of the electron or energy level of the electron will be numbered and will be called as principal quantum numbers. Okay. First one, stationary states. Stationary states or energy level states of a electron can be numbered and called as principal quantum number principal quantum number. You have to underline this particular word, principal quantum number. We are going to discuss this principal quantum number. We will come across once again when I will be talking about quantum mechanic model for the atomic structure. Got my point? So that's where stationary states or energy level of electron can be numbered and called as principal quantum number. Symbol is n. So therefore n can be equal to 1, 2, 3 like that. It will go on. Where n can be equal to 1, 2, 3, it will go on. So that's where principal quantum number, symbol is n. All of you have understood? Stationary states or energy level. No problem. With any of these words you can call it. So energy level of electron can be numbered and called as principal quantum number, where n is equal to 1, 2, 3, and as the electron will move away from the nucleus, n value is going to increase. Okay? Fine. So next part. Even he talk about radius of these stationary states or radius of this energy level. Okay. So next one is radius of an stationary state. Stationary state is Rn is equal to A naught into n square divided by z. A naught into n square divided by z. So what is z? Z is atomic number. Okay. So anyway, for hydrogen z will be equal to 1. So we can simply write it as Rn is equal to A naught into n square. A naught into n square for hydrogen only. Since we are talking about Bohr's atomic model, we can tell Rn is equal to A naught into n square. Otherwise, there is a divided by z is there, atomic number. Okay. So now, A naught value is somewhere around 52.9 picometer. 52.9 picometer. All of you have understood? So that is A naught value, which is a constant. Okay. And now some people they will call it as Bohr's radius, because for hydrogen atom there will be presence of only one electron. So this value can be applicable for that. Hydrogen atom is having only one electron. So 52.9 picometer can be applied for hydrogen atom. So therefore they will call it as Bohr's radius. They will call it as Bohr's radius. Okay. So this is what? Radius of the stationary state. Even he spoke about the radius of the stationary state. All of you have understood? Next, even he spoke about energy. Energy of an stationary state or energy level. Energy of an stationary state or energy level is, which we have already discussed, is En is equal to minus RH n square divided, z square divided by n square. Right? Z square divided by n square joules. So that's what the equation for energy. For hydrogen it will be, for hydrogen En is equal to minus RH z square. So this is applicable for hydrogen. Right? Z square joule. I will write it as joule. So that's where we have the energy of an electron present in a energy level. So please remember, energy of a stationary state, it is not related to orbit or it's not related to energy level. It's actually related to the electron present in that particular energy level. So what I mean to tell here is, please remember, on all this statement we are talking about stationary state. So that is nothing but stationary state, which talks about position of the electron around the nucleus. Okay? Now, whatever properties we are telling, it's not related to this particular circle. It is imaginary. It is related to electrons present in those energy levels. Okay? So that's what it means. Energy of the electron present in that particular stationary state is, that also fine. So that's what it tells. All of you have understood? Any doubt? Okay. Now, next one. Velocity of the electron, because it is moving in a circular path, right? So therefore, velocity of an electron will increase will increase with atomic number. Will increase with atomic number. Velocity of the electron will increase with atomic number. Okay? Now that is one thing. Same way, velocity of an electron will decrease with increase in the n value, with increase in the n value or radius, whatever it is, with increase in the n value or radius. So that's what it talks about. All of you have understood? So what I mean to tell here is, I have two atoms. Okay, this is hydrogen atom and I have helium. Now what I will do is, one electron of helium I will remove it. Now I have got helium plus. What is that? Similarity between helium plus and hydrogen atom? Any one of you? What is that similarity between helium plus and hydrogen atom? Any one of you? Helium plus and hydrogen atom. What is that similarity? Similarity between helium plus and hydrogen atom. Anyone? Okay, very good. Both have one electron. Yes, both have one energy level. Absolutely right. But very specific answer is, both are having same number of electron or both are having one electron. All of you are absolutely correct. So therefore, helium plus, I will call it as isoelectronic species 2, related to hydroelectronic species related to hydrogen atom. So therefore, helium plus, I will call it as isoelectronic species with respect to hydrogen atom. All of you have understood? So iso means same, electronic, that is related to arrangement of the electron. So isoelectronic species are those which are having same number of electron in their energy level. All of you have understood? So that's what helium plus can be the example for isoelectronic species. Same way, I can take lithium plus 2, which is also an example for isoelectronic species. So what I mean to tell here is, few examples like hydrogen, helium plus, lithium plus 2, because lithium is having 3 electrons, but I have removed 2 electrons, therefore lithium plus 2. So all of them, they are example for isoelectronic species. Okay. Now what do you mean by isoelectronic species? These are the elements which are group of elements which are having same number of electrons in their energy level. Anyway, I will come to that one, but for time being you have to understand. Now you should tell me, if you have understood this last statement, you should tell me that an electron present in helium plus and electron present in hydrogen atom, which will have higher velocity. An electron present in helium plus or an electron present in hydrogen atom, which will have the higher velocity. Okay. So Stephen has written hydrogen atom. All of you will agree? Okay. Sinchana, she is giving a different answer and she is absolutely right. See this statement. velocity of an electron will increase with atomic number. Now if you observe here, atomic number of helium is 2, atomic number of hydrogen is 1. Whether I am talking about helium plus or helium, atomic number will remain same. It is 2. That means atomic number of helium plus is high compared to hydrogen atom. Therefore, electron which are present in the same stationary state, still this electron will have higher velocity because velocity will increase with the atomic number. That is to avoid the falling of electron into the nucleus. That's why velocity will increase. Okay. Now, if I compare with the lithium plus 2, where the electron velocity will be high? Hydrogen, helium plus or lithium plus 2? Where the electron velocity will be more? Okay. So, I have hydrogen, then I have helium plus, then I have lithium plus 2. Velocity of the electron, where it will be more among these three? All of you are right. Very good. So velocity will goes on increasing. Velocity will goes on increasing because lithium is having highest atomic number among these, right? So where lithium atomic number is 3, lithium plus 2, helium plus 1 is 2 and hydrogen is 1. So therefore velocity will increase in the lithium plus 2, although in all the three cases they are present in energy level 1. They are present in energy level 1. All of you have understood? Any doubts? Please remember, whatever I have written here, this equation is applicable for hydrogen-like species because atomic number is different. This is for hydrogen. This is for hydrogen. Whatever I have written, it is applicable for hydrogen-like species like helium plus, lithium plus 2 and all. But whatever I have written here, it is applicable for hydrogen. All of you have understood? Whatever is there in the box, it is applicable for hydrogen. Whatever is there, okay. I have not written n square. Instead of that, no one has told me also. Okay, so whatever I have written in the box, it is applicable for hydrogen atom. Even this is applicable for hydrogen atom. But whatever I have written without the box, they are applicable for hydrogen-like species. They are applicable for hydrogen-like species. Please, if you don't remember all these things, if you don't remember all these equations, but in the exam they have asked about Bohr's atomic model. So what you can do is, first 4 points, along with that, you can write at least this point about principal quantum number. That will fetch you complete 4 marks. All of you have understood? If you don't remember all these things while writing those answers, no need to take tension. Okay? So what you can do is, whatever 4 points already we have discussed, that 4 point has to be written, and even this one you can write about the principal quantum number. There is nothing, no equation. So you will get the complete marks. Fine? All of you have understood? Any doubts? So hydrogen spectra, many times they have asked. Same way, Bohr's atomic model also, many times they have asked. Any doubts in this? So what and all you are going to write if hydrogen, Bohr's atomic model it is asked? First statement should be, it is based on the hydrogen spectra. That should be your first statement. Okay? Now, second, postulates you should go on writing. So first postulate talks about orbit. Definite path for the electron. That word has to come. Definite circular path called as orbit. The definite path and orbit it has to be written. Okay. Now second point, you should talk about energy of the electron or position of the electron will not going to change. Then you should talk about Bohr's frequency rule, third point. Okay. So which talks about a definite amount of energy of radiation will be taken by an electron to move to the higher energy level. So that definite amount of energy or definite amount of frequency of radiation, definite, that word has to be there. Okay. Then you should talk about position of electron, why it is decided. That is because angular momentum is equal to n into h by 2 pi. If you don't remember MVR, that is fine. You can just mention angular momentum of an electron. You should mention angular momentum of an electron is equal to n into h by 2 pi. Okay. So all of you have understood. So then last one you should tell that stationary state of an electron can be represented by principal quantum number n is equal to 1, 2, 3 like numbers. That can be the one. Okay. So rest of the things you can write if you remember, and it will help you in solving some of the problems. And final statement, the last conclusion statement is Bohr's atomic model. It is nothing related to postulate. If you remember, you can write this one. Bohr's atomic model is applicable for hydrogen-like species also. Is applicable for hydrogen-like species also. Okay, hydrogen-like species also. Example can be helium plus, lithium plus 2, etc. They are all the example for hydrogen-like species. All of you have understood? So in that case, don't write carbon plus 3. Okay? So don't write, goes on writing like this. Okay? So all the electrons cannot go to plus 2, plus 3, any of the state, which you will understand once periodic classification and redox reaction is done. But for time being, you can write helium plus, lithium plus 2, even beryllium plus 3, all these things you can write. Okay? But you cannot write carbon, nitrogen like that, goes on writing with whatever plus charge is required. No, that is not done. Okay? So these three can be taken as the example for hydrogen-like species. Okay? Now while explaining that one, even I spoke about isoelectronic species. This is nothing related to Bohr's atomic model. Okay, one more question can be asked. So isoelectronic species. Lithium plus 2. No sir, not lithium. We should write. I am not getting. Oh, okay. Okay, fine. 2 plus. Okay, done. Okay, now? Fine. But my question, okay, then we can write plus 2 plus 3. Okay? Why I have written like that? Because if I want to write negative sign, chloride minus we will write, sulfide minus 2 we will write. Right? So for that reason I have written this. Okay? So no issue. Fine? So now we have the isoelectronic species. 2 minus, yes, you can write. So just to tell that there is a reduction of or increase in the number of electron by 2. Okay? So plus 2 means there is a decrease of electron by 2. Okay? All of you have understood? So that's where we can write like this, or 2 plus 3 plus 5. Okay na? So that's why. Isoelectronic species. So what do you mean by isoelectronic species? This will be the last concluding statement for Bohr's atomic model, if you remember. Otherwise, it's not compulsion. Okay, that is one of the advantage of Bohr's atomic model. But there are limitations also that we are going to discuss. But now, before that, what I mean by isoelectronic species? Now I can tell that these are the group of atoms and ions having same number of electrons. That's what we have observed with respect to hydrogen. Example can be hydrogen, helium plus, then lithium 2 plus, then beryllium 3 plus. This way also we can write Rohan. Okay, so that's what examples for isoelectronic species. All of you have understood? Same way. So only this one? No, these are the isoelectronic species related to hydrogen-like species. They are nothing but isoelectronic species related to hydrogen-like species. You can give other examples. For example, sodium plus and neon can also be the example for isoelectronic species. They are not hydrogen-like species. They are the example for isoelectronic species. These are the example for isoelectronic species come hydrogen-like species. This is only isoelectronic species because both of them they are having 10 electrons. Neon itself it is having 10 electron. Sodium they are having 11 electron, but sodium plus has lost 1 electron, so therefore Na plus is also having 10 electron. But their atomic number still they differs. Atomic number with respect to number of proton, here it is 10, here it is 11. Still they differs in their atomic number. Isoelectronic species cannot have same atomic number. Some students they will write isoelectronic species are those which are having same atomic number. No, that is wrong. That can be considered with respect to isotopes, not isoelectronic species. Okay? All of you have understood? Any doubts related to this? Any doubts? Okay, in that case, this is with respect to Bohr's atomic model. Shall we solve some of the problems? At least for today, one problem at least we will solve. Okay, so now first we'll solve small problems related to frequency, wavelength and all. Okay, so now you can write it down. A periodic wave with wavelength is equal to 2 meter has speed 4 meter per second. It is not new, V, 4 meter per second. What is the wave's frequency? What is the wave's frequency? So they have given about wavelength, they have given about the speed. Okay, but they have asked about what is the frequency. Any one of you? Okay. So now here we can solve it by using equation where nu is equal to C by lambda. Nu is equal to c by lambda. What is c? C is related to speed. So c is related to speed of light. So we can write it as nu is equal to v by lambda. Nu is equal to v by lambda. So what is that v value? V value they have given 4 meter per second. And what is that lambda? So 2 meter. No need of conversion because both are in meters only. Both are in meters only. So nu is equal to 4 meter per second divided by 2 meter. So meter will get cancelled. 2 ones are 2 twos are. So that means 2 per second. 2 per second. So which is nothing but 2 hertz. Anything is fine. Both can be written as the answer. Okay. So therefore frequency will be 2 hertz. Right. So velocity or speed divided by, not velocity, speed divided by wavelength. That is nothing but frequency. Therefore nu is equal to 2 hertz. All of you have understood? So while writing the symbolic representation, you should be careful. It is V, speed, or velocity, capital V. This is nu, frequency. Both are not same. Okay? All of you have understood? Shall we move to the next one? Fine. So we'll move to the next one. Last problem. Okay. So calculate the next one. Calculate the energy of 3 moles of 3 moles of photons of a radiation having 5 into 10 to the power of 15 hertz. Having 5 into 10 to the power of 15 hertz frequency. Okay. So what I will do is, this one you can take it as a homework. So while coming tomorrow, you can try it out. Okay, any doubt? Anyway, I will be solving here. So calculate the energy of 3 moles of photons of a radiation having 5 into 10 to the power of 15 hertz frequency. Okay. So all of you have understood? All of you have understood this question? So this one you can take it as a homework. But not only this one, you should practice hydrogen spectra, Bohr's atomic model. Okay? And another important thing here is, if you want any notes and all, you can go to college and you can take check sheet. Okay? So I will not be having soft copy with me. So that's why I am telling. Okay? So and if you are in the group, WhatsApp group, they might have forwarded, teachers might have forwarded the check sheet, soft copy of the check sheet. Fine? And any doubt, you can contact me, no problem. My number, it is there in group, 9844259203. Okay, you can contact me, any doubts and all. No need to hesitate. But the only thing is, you should tell me your name and college. And as I told, I am very poor with respect to remembering the names. Okay, but if you tell me college and all, easily I can recognize. Okay, thank you very much. Take care. Okay, thank you. Thank you.